Hello, PascoMath grade 8 teachers. Today we're going to look at 8.EE.1.2. We're going to unpack the standard a little bit, look at what the teacher should be doing in the classroom, as well as what the student should be doing, and anticipate some misconceptions students might have and some things you can do to address those misconceptions. So when we look at the standard, the language of the standard says use square root and cube root symbols to represent solutions to equations of the form x squared equals p and x cubed equals p, where p is a positive rational number. Evaluate square roots of small perfect squares and cube roots of small perfect cubes, and know that the square root of 2 is irrational. So there was a lot there, so let's take a moment to unpack it. And so the first piece is really looking at students need to learn that squaring and cubing numbers are inverse operations to find the square and cube roots. Really build on that earlier work. They have experience with solving equations in grade 6 and grade 7, so that inverse operation language should be there, and just connect it to squaring and square root and cubing and cube root. Focus on perfect squares and perfect cubes, and students should start to recognize those numbers. Equations should include numbers, rational numbers such as x squared equals a fourth and x cubed equals 1/64. And square roots can both be positive and negative, meaning like if we took the square root of 4, 2 times 2 gives you 4, but negative 2 times negative 2 also gives you 4. And so emphasize that there are different representations when you take a square root, both positive and negative. So let's look at what the teacher should be doing. And so the teacher can introduce squaring a number and taking the square root as inverse operations, and then also taking the cube root and cubing a number as inverse operations. So those are operations that undo each other. Relate perfect squares and perfect cubes to geometric squares and cubes using square tiles and square cubes. So again, we want to see some hands-on learning going on there. And then also encourage students to explore patterns in a list of square and cube numbers. And so what we mean by that is, so if we just said a list of squares, so we can do, I'm just going to do x, and list out some numbers. So we have 1, 2, 3, 4, 5. I think that should be enough. Let's just throw in 6. So we have that, and then let's explore the squares. So x squared. So from there I have, well, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 25, 36. And then ask them to start finding patterns, like what did they notice? And so some students will see that, well, you add 3 here, you can add 5 there, you can add 7 there, you add 9 there, you add 11 there. And then someone will say, well, that's just 2 more for each time you go down the row. And so for this one, if we actually went to 7 squared, if you couldn't remember that it was 49, but you couldn't remember what 6 squared was, we know we just add 13 to it to get to 49. So that's one way of exploring squares in that pattern. Like, what does it mean when the first difference, if you connect to talking about linear functions, the rate of change, like if that first change isn't constant, we know this thing's not linear, but that second difference was constant, so now we know this thing's quadratic, and so some good conversation can happen there to pay that forward. We also can do the same thing looking at cube roots. And so if I took the same thing, but I wanted to look at the third, and so we have still 1, 8, 27, 64, 125. And so we can again start to explore what's going on here and have them look for patterns. And so students, again, can see that, well, maybe this is plus 7. And then I think this is 19. We have 37 and 61. And so like there's no pattern going on really there that we could see right off. So what about the next? So I'll go to the next level. Well, that's 12 different. That's 18 different. That's 24. And so then I start to pick up on the pattern. And so the third layer here, 1, 2, on the third layer here, I got that constant difference. And so I know this thing's cubic. And so again, just have them explore some patterns, because there are a lot of neat patterns that happen, and I hope them make sense of the cubes, squares, and actually start to recall perfect squares and perfect cubes maybe quicker. We also can facilitate discussion around in the equation x squared equals p. Can p be a negative number? So again, if we're talking about, we can just say x, so anything squared. So so we're asking x squared equals p. Can that p ever be negative? And so the answer is no, not in our real number system. And so we can have just some discussion around why. And again, anything times itself, so they can maybe explore like what happens if you do plug in a negative number for x. So if you plug in any negative number, -1 times -1, well, that gives me a negative times negative is a positive. It's some good discussion around that. And also discuss non-perfect squares and non-perfect cubes as irrational numbers. The standard actually calls out the square root of 2 specifically. So there can be some good conversation around that. Now moving on to what the students should be doing. They need to recognize perfect squares and perfect cubes. And so I want to say recognize, not memorize. I want to distinguish between the two. If students need to make some lists, like a reference to go back to and refer back to, I think the more they work with it, the more they explore patterns, then they'll start to recognize what there are perfect squares and perfect cubes and not have to rely on writing them out every time. Also, solve equations containing cube and square roots. They're expected to do that. They need to discover and explain the relationship between square and cube roots and the sides of a square and the edges of a cube, respectively, using hands-on materials again. And then reason with non-perfect squares and non-perfect cubes that they're irrational, including the square root of 2, specifically because the standard calls the square root of 2 out. So some misconceptions. Many students will struggle with finding cube roots as this is a new concept to them. They're a little bit more familiar with squares, squaring a number, than taking the cube or cube root. Then also a common error is a belief that any number, when you cube any number, is just that number times 3. Just like you had that misconception when squaring a number is like multiplying by 2. We know that is not the case. It's using that number as a factor twice. So we need to just reason with the students, have them write it out, expand it out. So what does it actually mean to cube a number? Is to use that number as a factor 3 times. And so I would definitely have them write it out. So provide multiple opportunities and exposures of perfect cubes is one good way. And have students create a perfect square and perfect cube fact sheet just as a reference for that. So that's it for 8.EE.1.2. If you have any questions, feel free to contact me or your regional specialist. And thank you for making PascoMath more awesome.